My name is Ibnu Jeng from IITA, and together with colleagues from CIMIT, we present ViTSel, a user-friendly tool to ease selection using results of multi-environment, multi-trait analysis. Through the EIB Module 5 short-term sabbatical program, aiming to provide opportunities for members of the bioinformatics, biometrics, and data management COP to expand collaboration across CGIAR centers, we developed ViTSel, a new decision support tool to facilitate the selection. This sabbatical program is innovative in the sense it allowed for 1 month to concentrate efforts and critical mass on a particular topic to address similar concerns to CGIAR centers and beyond. Why ViTSel? There are already various tools to run statistical analysis on raw data after breeders accomplish the evaluation of performances offline in a single or group of environments. Output of these analyses are usually descriptive statistics, means of genotypes, heritability, etc. But how to consider and combine all this output in a single interface to allow breeders after running analytics to quickly and easily make a decision? ViTSel, a new R-Shiny-based interactive application, is intended to answer the above question. We assume that statistical analysis using mixed model has been carried out and a genotype by environment table with blues is available. The application has 2 components, a visualization component and a line selection assist component. Different defined criteria are available in ViTSel to identify the best genotypes matching those criteria. For example, we can compare genotypes to check. We can use standard values and rank the genotypes based on these values. And we can use index selection as well. ViTSel meets needs for breeders to investigate and visualize genotype by environment interaction. Multi-trait and multi-environment analysis are considered together in one single interface for quick visual assessment. The objective of plant breeding is to develop varieties with better characteristics. Selection of the best genotypes either to push to farmer's hand or through cycling. Consider them as parent for future crosses. Then we can compare the new genotype we are testing to 1 or more checks. For that, we want genotype with higher values for some trait, for example, the yield, with lower values for other traits, for example, days to flowering, and between range values for some other traits, for instance, plant high. The genotypes matching those criteria are in green or in red otherwise. And a breeder will be more than happy to see one genotype with all its values that are green. And alongside the performance of the genotypes, we also have the Shukla rank stability. The output can be exported to Excel for further manipulation, either filtering or sorting or whatever manipulation that can be of interest. 2 methods of index selection are also available: the rank summation and the base index. For the rank summation index, the breeder selects the traits of interest, and for each the best genotype is rank number 1, the second best is rank number 2, etc. The sum of all rank provides the rank summation index. For the base index, the traits are standardized and weighted. Their sum is the base index. Each weight is assigned by the breeders according to the importance of the traits. We can see here that yield is more important than plant height, which is more important than flowering dates based on this ranking. For the visualization, box plot, heat map, biplot, and scatter plot are available. For the box plot, we have the variability within and between environment for each trait. We can pick quickly the high yielding environment and the environment that are nearly different. For the heat map, we use the principle of Wu-Won-Ware alongside with the scale color. Darker the color, better the varieties. If you consider higher values, the yield, for instance, we can easily pick and see the best genotypes in one or more environment based on the color. What's next? ViTSel is a tool to contribute to support resource poor farmers in Africa, Asia, and Latin America accessing better varieties. But the intermediate beneficiaries are the breeders from CGIAR, NARS, and Advanced Institutes. The first version is available in CIMMYT's and IITA open data repositories, and feedback are still being captured for further improvement. But EBS is in the pipeline that support the integration of genotypic, pedigree, and phenotypic information in selection decisions. As member of the EIB community, our contribution is to adopt, share ideas and tools. In that vein, we propose ViTSel, aiming to develop analytics and visualization tools for breeders and consider this as a short-term win. Indeed, we could test and develop a simple tool focusing on only 1 or 2 more components in the data management and analytics workflow. We see this as a proof of concept, and if successful, to be vested in a broader initiative, either partially or totally. Because, and ultimately, the EBS connects, merges, builds upon existing breeding software and data solutions to offer a single powerful tool so that breeders can focus on using data to create better varieties faster. That was my last slide. Thank you for listening.